So now the other half is about AHB. So everything that we discussed in APB remains same. Like the base is that how the write transfer happens, how the read transfer happens. Everything revolves around that. So the extra things that ASB have, we'll try to see and we'll try to understand that. So reset and clock the global signals which we have seen. HRD as I've mentioned, which is in the output to the master. So it is an input to the master. Now this says that either slave is ready or not in order to do the transfer or complete the transfers. There is one additional signal which is H response. So both of this combined into so each we in the program have written as H response. So we have a combination of this two, which shows what the slave is, what state the slave is in, and what should be the response that master should give with respect to that. And the other signals which were the inputs to the slave are H address and 32 bit is the standard thing which even in the program we have written. But 128 I think we'll see when we go down. H right is as usual, which is representing the APB thing. Clearly representing how many bits
Danny,
your
Dan, your
hello.
voice is buffering, like it's not continuous.
I thought my even my signal is gone now.
Okay.
I think
Now, what about now?
now it's a bit fine, Is
Yes, yes.
continue. If anything happens like that, we'll interrupt you one second.
Yeah, fine. So,
Please repeat. Please repeat.
yeah. So, H address from where should I repeat it?
From these transfer response, HRD and S response. H response.
Okay. So, H response, these two we have written in the code as a 2-bit data and which is named as H response. So, both of them make both of the signals together tries to give some information about the slave, how it is working to the manager. So based on the values in these two signals, the manager will decide what to do with respect to that. We'll go in detail how this HRD and H response are making the status of slave, how the status of slave being represented by these two signals, and then H read data, which is a read that is been coming from the slave to the master after giving the address to the slave by the master, which is everything stays similar when we are coming. So the transfers and all will stay similar. The only additional things that we have is H size. H size basically represents in one transfer. So in one transfer, how much of data are you sending? It is one byte or it is 2 bytes, what it is. It is one word or two double word. So it will be this four, this 3 bits will decide how much is the size of data that you are transferring in one transfer. So in a single transfer, how much data you are sending to the other side, slave. Okay, and H burst represents. Uh, so burst is something that is new in the AHB. So burst says that by the name it says that you are bursting the data out of it. So when you say you let's say you have a particular set of address in a slave and collection of those data in that particular range of address will make something that is informative that particular
Danny,
Danny,
once
many
again,
voice
things.
it's buffering.
voice is breaking.
Danny,
Voice is breaking.
ವಾಯ್ಸ್ ಇಸ್
Oh.
ಬ್ರೇಕಿಂಗ್ ರಾಜನಿ.
It's okay.
ಕಂಟಿನ್ಯೂ ಸ್ಟೇಟ್ಮೆಂಟ್.
Okay, I'll try to come to SSH. One second.
Come.
Yes.
Come Dani. ಲೈಕ್ ಕರಿಮಲೆ ಆನ್ ಮಾಡೋ ಸತಿ ಹಚ್ಚಿತ್ತು ನೋಡೋಣ.
ಏನು ಇಲ್ವೋ, ಬರೀ ನನ್ನ ಮೌಸ್ ಕಾಣಿಸುತ್ತೆ ಅಷ್ಟೇ.
ಮತ್ತು ತೋರ್ಸು.
ಕಾಣಿಸಲ್ಲ,
ಬರೀ ಮೌಸ್ ಕಾಣಿಸುತ್ತೆ ಅಷ್ಟೇ ನೋಡು.
ಏನೋ ಅದು ಮನೇನ ಏನು ಅರಮನೆ ಏನೋ. ಹೌದಲ್ಲಿ
ತೆಂಗಾಳ ಏನಿಲ್ಲ ಈ ಶಾಟ.
ಯಾವ್ದು
ಮೌಸ್ ನೋಡು.
ಒಳ್ಳೆ ಸ್ಪೈಡರ್ ಮ್ಯಾನ್ ಅಂತ ಇದೆ.
ಬ್ಲ್ಯಾಕ್ ಸ್ಪೈಡರ್ ಮ್ಯಾನ್.
ಯಾವ್ದು?
ಗೇಟ್ ಹೆಚ್ಚು ಕೀಟು
ನೋಡಿಯೋ ನಕ್ಕ
ಹೊಡಿಬೇಕಾ?
ಪಟ್ಟಂತ ಕೊಡು ಒಂದು ಹೇಳಿ.
ಕೊಟ್ಟೆ ಕಳ್ತಾನೆ.
ಮಜಾ ಮಾಡೋಣ PG ಅಂತ ನೋಡೋಣ. ಸುಮುಖ ಮಲ್ಗ್ಬಿಟ್ನು ಏನೋ.
ಮಲಗಿಲ್ಲ ಅನ್ಸುತ್ತ.
ಎಷ್ಟ್ ಗಂಟೆಗೆ ಹೋಗ್ತಿರೋ PGಗೆ?
PGಗೆ ಹೋಗ್ಬೇಕು ಇವಾಗ. ಇವತ್ತು ಎಷ್ಟೊತ್ತಿಗೆ ಹೋಗ್ತಿರೋದಿಲ್ಲ, ಹೊಟ್ಟೋಗ್ತಿದ್ದು ಎಷ್ಟೊತ್ತಿಲ್ಲ ನಾವು ಯೂಶುವಲ್ ಆಗಿ.
ನಿದ್ದೆ ಬರ್ತಿಲ್ವೇನ್ರೋ ನಿಮ್ಗೆ? ನಾಳೆ ಬರ್ತೀಯ ಅಷ್ಟೇ?
ನಂದು ಇಂಟರ್ವ್ಯೂ ಐತವ.
ಏನ್ ನೋಡ್ದೆ ಅಲ್ಲ ಇವತ್ತು ದೆಂಗಾಗ್ಬಿಟ್ರಲ್ಲ. ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಲ್ಲ ಅವಳು. ನೀನ್ ಎಷ್ಟರ
ಯಾವ ಪ್ರೋಗ್ರಾಮ್ ಕಳಿದ್ಲು ನಿಂಗೆ? ಪ್ರೋಗ್ರಾಮ್ ಏನ್ ಕಳಿದ್ಲು?
ಎನ್ಕ್ಯಾಪ್ಸುಲೇಷನ್. ಅದೇ ನಮ್ಗೆ ಹೇಳ್ಕೊಟ್ಟಿಲ್ಲ ತಾನೆ. ಬಟ್ ಇವನ್ ಸುಮುಖ ಹೇಳ್ದ, ಹಂಗೆ ಬರ್ದೆ ನಾನು. ಪರವಾಗಿಲ್ಲ. ಅದೇನ್ ಗೊತ್ತಾ, ಅದೇನೋ ಫಸ್ಟ್ ಒಂದ್ ಕ್ಲಾಸ್ ಬರ್ಕೊ. ಕ್ಲಾಸ್ ಅಲ್ಲಿ 3 ಪ್ರಾಪರ್ಟೀಸ್ ತಗೋ. 3 ಪ್ರಾಪರ್ಟೀಸ್ ಒಂದು ಪಬ್ಲಿಕ್ ಕೊಡು, ಅಂದ್ರೆ ಇಂಟ್ ಎ. ನಾರ್ಮಲ್ ಆಗಿ ಡಿಫಾಲ್ಟ್ ಪಬ್ಲಿಕ್ ಅಲ್ಲ, ಸೊ ಇಂಟ್ ಎ ಕೊಡು. ಇನ್ನೊಂದು ಪ್ರೊಟೆಕ್ಟೆಡ್ ಕೊಡು, ಪ್ರೊಟೆಕ್ಟೆಡ್ ಇಂಟ್ ಬಿ ಅಂತ ಕೊಡು. ಇನ್ನೊಂದು ಲೋಕಲ್ ಇಂಟ್ ಸಿ ಅಂತ ಕೊಡು. ಓಕೆನಾ? ಆಮೇಲೆ ಇನ್ನೊಂದು ಕ್ಲಾಸ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡು. ಇನ್ನೊಂದು ಕ್ಲಾಸ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಬಿಟ್ಟು ಆಮೇಲೆ ಮಾಡ್ಯೂಲ್ ಒಂದು ಇದು ಟೆಸ್ಟ್ ಬೆಂಚ್ ಅಲ್ಲಿ ಇದನ್ನ ಈ 3ನ ಪ್ರಿಂಟ್ ಮಾಡು. ಅಂದ್ರೆ ವ್ಯಾಲ್ಯೂಸ್ ಏನಾದ್ರು ಕೊಡು. ಬೇಕಂದ್ರೆ ವ್ಯಾಲ್ಯೂಸ್ ನೀನು ಇನ್ಪುಟ್ ಮಾಡಿ ಆಮೇಲೆ ಪ್ರಿಂಟ್ ಮಾಡಿ ನೋಡು. ಯಾವ್ದ್ಯಾವ್ದು ಲೋಕಲ್, ಯಾವ್ದ್ಯಾವ್ದು ಪ್ರೊಟೆಕ್ಟೆಡ್, ಅದ್ರದ್ದು ಬಿಹೇವಿಯರ್ ಗೊತ್ತಾಗುತ್ತೆ. ಯಾವ್ದ್ಯಾವ್ದು ಪ್ರಿಂಟ್ ಆಗಲ್ಲ, ಯಾವ್ದು ಎರರ್ ಬರುತ್ತೆ. ಲೋಕಲ್, ಇವಾಗ ಲೋಕಲ್ ನೀನು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಾದ್ಮೇಲೆ ಲೋಕಲ್ ಬಂದು ವಿದಿನ್ ದ ಕ್ಲಾಸ್ ತಾನೆ. ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಾದ್ಮೇಲೆ ಬೇರೆ ಕ್ಲಾಸ್ ಆಯ್ತು, ಸೊ ನಿನ್ಗೆ ಎರರ್ ಬರುತ್ತೆ. ಆತರ. ಪ್ರೊಟೆಕ್ಟೆಡ್ ಅಂದ್ರೆ ಪೇರೆಂಟ್ ಕ್ಲಾಸ್, ಚೈಲ್ಡ್ ಕ್ಲಾಸ್ ಎರಡದು ಬರುತ್ತೆ. ಸೊ ಅದು ಔಟ್ಪುಟ್ ಬರ್ಬೇಕು ಆತರ. ಪಬ್ಲಿಕ್ ಅಂದ್ರೆ ಬಂದೇ ಬರುತ್ತೆ ಅಂತ.
ನಾಳೆ ಮಾಡೋಣ ಕ್ಲಾಸ್ ಎಲ್ಲ. ಇದು APB HB
ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಮಾಡ್ತೀಯಾ?
ಕ್ಲಾಸ್ ಮುಗಿದ್ಮೇಲೆ.
ಯಾವ ಕ್ಲಾಸ್? ಸೆಕೆಂಡ್
4 ಗಂಟೆ ಇಂಟರ್ವ್ಯೂ. ನನಗೂ ಇದೆ ನೋಡ.
ನಾಳೆ ಮಧ್ಯಾಹ್ನ.
ಇವಾಗ ಇದು 1 ಅವರ್ ಮುಗಿಸ್ಬಿಟ್ರೆ ನೀಟಾಗಿ AHB.
ಮಗ ನಾಳೆ ನಂಗೆ ಇಂಟರ್ವ್ಯೂ ಇದೆಯೋ, ಏನು ಓದಿಲ್ಲ, ಓದ್ಬೇಕು ಬರೇ.
ಮಚ್ಚ ನಾನು ಇವತ್ತು ಜೈ ಅಂತ ಬಂದಿದ್ದು ಗೊತ್ತಾ? ಜೈ ಅಂತ ಬಂದಿದ್ದು, ಆಗೋದಾಗ್ಲಿ ಅಂತ. ಇವತ್ತು ಗೊತ್ತು ಹೆಂಗೋ ದೆಂಗೋಗುತ್ತೆ ಅಂತ. ಎಷ್ಟು ಓದಿದ್ರು ದೆಂಗೋಗುತ್ತೆ ಅಂತ ಗೊತ್ತು.
ಮಗ ಅಜಿತಿಗೆಲ್ಲ ಗೊತ್ತು ಮಗ ಅಂತ ಹೇಳ್ತಿದ್ದ.
ಶಾರ್ಟ
ನಾನು ಹೆಲ್ಪ್
ಅರ್ಧ ಮುಕ್ಕಾಲ್ ಭಾಗ ಸುಮುಖನೇ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೆ ಬರ್ದಿದ್ದು.
ದಿಂಗೋ
ಸಿಸ್ಟಮ್ ವೆರಿಲಾಗ್ ಹೆಂಗೋಯ್ತು ನಂದು. ವೆರಿಲಾಗ್ ನಾನು ಯಾರು ಹೆಲ್ಪ್ ತಗೊಂಡಿಲ್ಲ, ಡಿಜಿಟಲ್ ಯಾವ್ದು ತಗೊಂಡು. ಸಿಸ್ಟಮ್ ವೆರಿಲಾಗ್ ಅಂತೂ ನನ್ಗೆ ಗೊತ್ತೇ ಇಲ್ಲ. ಹಿಂಗೋ ಸುಮುಖ ಬಂದ. ಇನ್ನೊಂದ್ ಏನಾಯ್ತು ಗೊತ್ತಾ, ಮೈಕ್ ಆನ್ ಅಲ್ಲಿ ಇತ್ತು, ಸುಮುಖ ಅದೇನೋ ನೋ ಚೇಂಜ್ ಲೋ ಅಂತೇನೋ ಕಿರಿಸ್ತ, ಬಾಯಿಗೆ ಬಂದ್ಬಿಟ್ಟಿತ್ತು ನನ್ಗೆ. ಮೈಕ್ ಅವನ ಹತ್ರ ಇತ್ತಲ್ಲ, ಇಯರ್ಫೋನ್ ಶೇರ್ ಮಾಡ್ತಿದ್ವಿ, ಅವಳು ಐ ನಾಟ್ ಏಬಲ್ ಟು ಇಯರ್ ಅಂದ್ಬಿಟ್ಲು ಅವಳು. ಮ್ಯಾಮ್ ಕೆನ್ ಯು ಇಯರ್ ನೋ ಅಂತ ಹಂಗೆ ತಿರ್ಗಿಸ್ಬಿಟ್ಟೆ ನಾನು. ಸಂಜಯ್ ಇದ್ರೆ ಗೊತ್ತಾಗ್ಬಿಟ್ಟಿದೆ ಅದು, ಸಂಜಯ ಮೈನಕ್ಕೋ ಪಕ್ಕದಲ್ಲಿ ಯಾರೋ ಅವ್ರೆ ಅಂತ. ಹೆವಿ ಹಿಡಿದ್ಬಿಟ್ಟಿದ. ಏನಾಯ್ತು ಡಿನ್ನರ್ ಇವತ್ತು ಚೇತು?
ನಾರ್ಮಲ್ ಅದೇ ಗೋಬಿ, ಚಪಾತಿ, ರೈಸ್, ರೈ
ನೋಡು ನಿಂದು ವಾಯ್ಸ್ ಹೆವಿ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ಏನೋ ಇವತ್ತು, ಹೆವಿ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ವಾಯ್ಸ್ ಎಲ್ರದ್ದು.
ಡ್ಯಾನಿ, ಇಯರ್ಸ್ ನೆಟ್ವರ್ಕ್ ಇಸ್ ನಾಟ್ ಸ್ಟೇಬಲ್. ಸೀರಿಯಸ್ಲಿ
ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ ಕಾಲೇಜ್ ಆ ಥರ ಇದೆಯಾ?
ಕಾಲೇಜ್ ಡಾಟಾನ ಹಾಕಿರೋದು ಬಫರ್ ಆಗ್ತಿತ್ತು. I tested the speed. It's showing 200 Mbps, but here it's not showing. Hey, some phone is coming.
ಈ ಲ್ಯಾನು ಕನೆಕ್ಟ್ ಆಗ್ತಿಲ್ಲ ಅಷ್ಟು. ಇವಾಗ ಕೇಳಿಸ್ತಿದ್ಯಾ?
ನಿಂದು ಕೇಳಿಸ್ತಿದೆ ಇಲ್ಲಿ ಸದ್ಯದ್ದು.
ನಂದು ಸ್ವಿಚ್ ಮಾಡಿದೆ ವೈಫೈ ಇಂದ ಲ್ಯಾನ್ಗೆ, ಇವಾಗ ಕ್ಲೀನ್ ಆಗಿ ಕೇಳಿಸ್ತಿದೆ. ಎಲ್ಲಪ್ಪ ಗೆಂಡೆ,
ಹೇಳಪ್ಪ ಗೆಂಡೆ ಅಂತ.
ಏನೋ ಕಟಿಂಗ್ ಮಾಡಿಸ್ಬಿಟ್ಟಿದ್ಯಾ ಶಿಷ್ಯ?
ಕಟ್ಟಿಂಗ್ ಮಾಡ್ತಿದಾರ ಕಾಣ್ತೈತೆ ನಿಂಗೆ ಅವನು.
ಸೈಡ್ ಅಲ್ಲಿ ಮಾತ್ರ ಬ್ಲೇಡ್ ಹಾಕ್ಸೋಣ ಅಷ್ಟೇ ಶಿಷ್ಯ.
ಏನ್ ಕಟಿಂಗ್ ಮಾಡ್ಸೋನು, 60 ರೂಪಾಯಿ ಅಂತೆ ಕಟಿಂಗ್ಗೆ.
ಎಲ್ಲಿ ಅದೇ ಮಾತಾಜಿ ಪಿಜಿ ಪಕ್ಕದಲ್ಲ
ಮಾತಾಡಿ ಸ್ವಲ್ಪ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ. ಇನ್ನು ಮುದ್ರೆ ನಡೆವಿ
ಸುಮ್ಮನೆನಾ? ಇದು ಎಫೆಕ್ಟ್ಸ್ ನಂಗೆ ಮೀಟಿಂಗ್ ಹಿಂಗೆ ಕಳಿಸು, ನಂಗೆ ನೋಡಿ ಎಷ್ಟು ವೇಟ್ ಆಗಿ ಬರುತ್ತೆ. ಬಟ್ ಬೆಳಿಗ್ಗೆ 3
ಸದ್ದು ನೋಡೋ ಮೆಸೇಜ್ ನೋಡೋನೆ ಮಲ್ಕೊಂಡ್ಬಿಟ್ಟವನೆ.
ಬಿಡು ಹುಡುಗ ಟೆನ್ಷನ್
ಈ ತರ
ಬಂದ ಮಗ.
ಸಾಕಾಗಿತ್ತು, ವಾರ ಬೈಸ್ಕೊಂಡು ಈಗ ಥರ್ಸ್ಡೇ ಎಕ್ಸಾಮ್ ಇದೆ, ಫ್ರೈಡೆ ಸ್ಯಾಟರ್ಡೆ. ಚಂದ್ರಶೇಖರ್ ಯಾವ ಸರ್ ಏನು ಸಂಬಂಧ ಇತ್ತು? ಪೇಪರ್ ಕೊಡ್ತಾರೆ, ನಾವು ಬರೆದು ಹೋಗ್ತೀವಿ ಅಷ್ಟೇ. ಚಂದ್ರಶೇಖರ್ ಯಾವ ಫುಲ್ಲಿ ವೆಬ್ಸೈಟ್ಲಿ ಇದು ಹೌದಿಲ್ಲ? ಎಷ್ಟು ಸಲ ಅದನ್ನ ಓದಕ್ಕೆ
ಅದೇನೋ ಆಫ್ಲೈನ್ ಏನೋ, ಆಫ್ಲೈನ್ MCQ ಆಫ್ಲೈನ್
ಆಫ್ಲೈನ್ ಕಣವ.
ಗೊತ್ತಿಲ್ಲ ಕಣ.
Now it is stable or still there?
Go on bro.
ಬುಚ್ಚರು ಅದನ್ನ ನೆಟ್ ಬರ್ತಿಲ್ಲ. ಮೋಹನ್ ಬಾರ ನಮ್ಗೆ ಬರ್ತಿಲ್ಲ. ಮೋಹನ್ ಬಾ.
ನಮ್ದೋಯ್ತಾ ಏನು?
Okay. Yes.
Danny, the speed will be proper only, but while you explain, no, your voice will suffer.
ಇವಾಗೂ ಅಷ್ಟೇ ಅದು ನೋಡ್ದ ಅದು
Speed even
ಬ್ರೇಕ್
I
ಬ್ರೇಕ್
checked.
ಆಯ್ತು.
It was 200 Mbps, okay, upload and download also. But when we start streaming the video, then it will.
ಹೌದು ಅವಾಗ್ಲೇ ಕರೆಕ್ಟ್ ಆಗಿತ್ತು APB ಇದು ಫುಲ್ ಸ್ಮೂತ್ ಆಗಿತ್ತು.
Okay, we'll try till what we can go. If it is continuously happening, then we'll try to do some other thing. Okay, so now it is okay, no?
Yeah, go
And,
ahead.
when there is any glitch or something, say.
Danny, once again,
Okay,
voice breaking.
so
ಆಯ್ತಲ್ವಾ ತಿರ್ಗಾ?
Danny, voice it's like
ಚಾರ್ಜಿಂಗ್ ಹಾಕೊಂಡು ಟ್ರೈ ಮಾಡೋ.
as soon as you start, no, like it will suffer.
ಇನ್ನೊಂದು ಮಾಡ್ಬೋದು ಏನ್ ಗೊತ್ತಾ, ಫೋನಲ್ಲಿ USB ಟೆದರಿಂಗ್ ಆನ್ ಮಾಡಿ USB ಕನೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ಅದು ಒಂದು ಆಪ್ಷನ್.
that only I am doing. Which one?
ಮಾಡಕ್ ಕ್ಲಾಸ್ ಅಲ್ಲೇ ಮಾಡೋಣ ಬಿಡ್ರ. ಈ ವಾಯ್ಸ್ ಸ್ವಲ್ಪ ಡೇಟಾ ಬಫರ್ ಆಗ್ತಿದೆ.
ಯಾಕೆ ಹಂಗ ಆಗ್ತಿದೆ ಅಂತ ಗೊತ್ತಾಗ್ತಿಲ್ಲ.
ಡ್ಯಾನ್ ಕರಿ ನಿಕ್ಕಿಲ್ಲ
ಇದೇ ಮುಟ್ಬೇಕಾ ನೀನು
Sumuka. You might not, huh? Yeah, you said I'll try to send you one second.
Oh, Danny.
Wait.
Maybe restart the PC once.
Okay.
ರೀಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಿಕ್ಕನೋ ಒಂದ್ಸರಿ ಗೊತ್ತಾಗುತ್ತೆ.
ಮಾಡ್ತೀನಿ ಅಂದ.
ಏನಪ್ಪ ಜಾಸ್ವಿ, ಏನ್ ಸಮಾಚಾರ?
ಬೂಟಿ ಮಾಡ್ತಿದ್ದೇನು? We'll do one thing tomorrow afternoon only. We'll do it here only. Tomorrow I have HB interview also.
Today you studied.
On three
PJ or result will come.
ಬಿಡೋ ಎಷ್ಟು ಓದಿದ್ರು ಹೆಂಗೋಗುತ್ತೆ ಚೇತನ್ ಎಷ್ಟು ಓದಿದ್ರು ಹೆಂಗೋ ನೇಹ ತಾನೆ
Try to complete.
ಈ ಸರಿ ಸಂಜೆ ಇರ್ಬೇಕಿತ್ತು ಚೆನ್ನಾಗಿ.
After class we'll sit here and we'll discuss. That's better.
ಏ ನಾಳೆ ನಾನು ಬರ್ತಿಲ್ವ ಚೇತನ್? ಗೂಗಲ್ ಮೀಟ್ ಆಗ್ಬೇಕು.
With most of the certificate online.
ಚೇತು
Do it with pen and paper.
ನಾನು ಬೇಕಾಗಿಲ್ಲ ಅವ್ನು ಬರಲ್ಲ ಅಂತ ನಾನು
ಯಾರು?
ಅದಕ್ಕೆ ಗೂಗಲ್ ಮೀಟ್ ಹಾಕೋಣ ನಾಳೆ ಬೇಕಾದ್ರೆ. ಇವತ್ತೇ ಹಾಕೋದಿದ್ರು ಓಕೆ, ನಾಳೆ ಹಾಕೋದಿದ್ರು ಓಕೆ.
ನಾಳೆ ಬರ್ತೀರಾ?
ಗೂಗಲ್ ಮೀಟ್ ಹಾಕೋಣ. ನಾಳೆ ಬರಲ್ಲ ಮೋಸ್ಟ್ಲಿ.
ಯಾಕೆ?
ಕೆಲ್ಸ ಚೂರು ಇದೆ, ಆಚೆ ಹೋಗ್ಬೇಕು. ಮಧ್ಯಾಹ್ನ
Share and start taking it to buffer. That's the reason.
Last look at a share.
This guy asked for a morning semaphore.
ಸೆಮಾಫೋರ್ ಫಸ್ಟ್
Sumka, you try to share your screen. I'll try to explain from here. Because of that, it is getting over.
Share from my PC.
Okay.
ಸರಿ ಹೆಂಗೆ ಹೇಳ್ಬೇಕಾ ಸೆಮಾಫೋರ್ just like a bucket with a fixed number of keys. Process that is semaphore just like a bucket. Before they can execute a
Spec sheet of AHB.
ವಾಪಸ್ ರಿಟರ್ನ್ ಬರುತ್ತೆ ರಿಟರ್ನ್ ದ ಕೀ
Okay.
one 3 4 next one
Go to signal descriptions. Not descriptions. You go to master of it. You guys are here only. No, it is in introduction only. No, down. Come down. Yeah. The master one.
ಈ ಸೆಮಾಫೋರ್ ಒನ್ಸ್
Okay, fine.
ನೆಕ್ಸ್ಟ್
ಯಾವ ನಿಖಿಲ್ ವಾಯ್ಸ್ ಕೇಳಿಸ್ತದೆ.
Go to master.
ಚಂದ್ರಗಾರ್ ಕೊಡ್ತಾನೆ.
ಸಿಂಟೆಕ್ಸ್
It is above only. Yeah, this one. So, in this, can I annotate? How? I can't, no?
You will share from my PC. You want to write?
ಇಲ್ಲ ಚೇತನ್ ನಿಂದ್ರಲ್ಲೇ ಮಾಡ್ಲಿ. ಟ್ರೈನ್ ಚೇತನ್
Danny. Which PDF?
ಅದೊಂದು
Specs. Take Why it is floating? With this it is floating. Look can hear.
ಸೆಮಾಫೋರ್
Come back. Open it. Yes, sir.
You can hear.
Sumka. Yeah, you try to. I share from here. Somebody start. Hello, Sumka.
Okay.
My sister. Hello, hey Sumka.
ಅವನೇ ಹೋಸ್ಟ್ ಮಗ ಹೋಸ್ಟ್ ನ ಇದ್ ಮಾಡಕ್ರಿ
Sumka.
ಬಂದು ಬಿಡೋ ಮಗ ನೀನು ಶೇರ್ ಮಾಡೋ ಸ್ಟಾಪ್ ಮಾಡು
Stop sharing now, Sumka.
ಎಷ್ಟು
Yeah, sharing. Okay, so this one, these two we know how it's working. These two are global signals for which are one is clock with respect to which all transfers will happen. One is reset where setting it so in reset there are two things. While you are asserting, while you are making it zero, so it is active low. While you are making zero, the irrespective of the clock means it works as asynchronous. But you are when you are deasserting and when you are when you are making it to pause edge, this is with respect to the synchronization of the clock. So when you are asserting it is asynchronous, but when you are deasserting it goes with respect to clock. That's the major difference that reset signal have in this AHB. And then clock is what which drives everything and which starts the transaction. Everything is with respect to clock. These two are just representing how slave is working and what state the slave is in. And then
this one
yeah, HR data is something that comes from the slave. Yeah, both of them tries to show the status of the slave, what status it is ready or it is. We'll come to see the modes of the slave, and HR data is that which comes out from the slave as a input for the master. H address, H write, and all we have seen. The two things that are a bit different in this is we are not considering this. We are not considering this, so we don't have to worry about those two signals. H size represents how many bits that you are transferring in one cycle or in one transfer. So you can vary this. This is configurable. H burst is something how many bits, how many transfers are you doing in one time. So this represents how many bits you are transferring in one transfer. This represents how many transfers that you are performing. So W data is what you write to the slave for a particular address. This one, right? Okay, this represents right. This represents H represent the AHB. That it is AHB. Okay.
not because
No, not like that. It is here H. That H represent. In that P represent AP. To differentiate among them, we'll use that. And up to here, it is clear. No? It is audible, right?
yes
Yeah, that's right. So after this, coming to the subordinate, which is basically a slave. and have everything as an input that comes output from the output of the master. HR data is basically which is input to the master, which is obviously an output, and this represent the status of the slave, how it is, and that's about the slave part, how it is.
So is it connected like a loop, master and slave?
Yeah, it's connected by a loop, but you have something called as interface in between. This
Okay.
whole thing is an interface. When you have multiple masters, then this whole interface will work as a arbiter. There will be one more component which is arbitrator that chooses which master should be selected
Okay.
at a particular point of time. So we don't go through that. We consider it the simple case.
Chooses
Okay.
randomly. Arbitrary to
No,
choose.
no, it chooses based on the priority that it goes on. It don't choose it randomly. It chooses the priority of the master and
What
the
master says according
yeah,
to
not like master says. There will already be a priority logic that will be written to this master. How should you give how much priority? So processor gets the highest priority basically, and the caches that are there in it get the second priority. So it depends on which is having more priority. That will be predefined in that arbitrator. When we go through that design, it will come out, but we don't want to discuss about that. And then yeah, this this is what sits in between, which is interface, and that makes sure which subordinate or slave need to be selected, and from that how what data should be given. So this makes sure that it is getting the right data from the right slave by selecting the right slave. Okay, and that's about that. About so coming to the transfers that happens in APV, and okay, so about burst also we'll see about burst, and then we'll see about head size, and then from the slave side we'll try to see what is H ready and what is H response. Okay,
remaining are not there.
remaining on all either they are common with the APB that we have discussed or which are not there. HR data we have discussed with APB, which is a yeah, PR data. So H select is like P select only. Everything is similar to that, and which are not there in APB, those are not considered here also. So everything remains same. The only difference that comes is how the transfers are working, how many transfers are there. There are operating states that how we discussed that. So these are the transfer types. So every time when you are transferring, that the transfer every time a transfer happens from using AHB protocol, you basically come across these states. You don't have to remember all this, but just for the knowledge of that, and this won't be used in the project also. The major,
It's like FSM.
yeah, it's not FSM. It's like it says because in this we have yeah.
Values are FSM. So
No, these are the select line, the transfer income. H trans. H trans indicates in what state the master is. So when master is busy, so base how we have from slave side H response and all. This indicates what is state in. Okay, so whether it is in idle condition, it is busy or non-sequential and sequential. Briefly about them is ideal is something where you don't have to do any transfer, and so slave should provide a zero weight state okay response. So this okay response is coming from it is a like interpretation of the H response and H ready out. So based on those two bit we'll interrupt this okay response. That will come to understand when we see those how those two bits are working. And then in a busy state that says that manager need to manager tries to say to the slave that you like like there are transfers that are remaining, but it is in the middle of the burst, and you need to wait. So it is basically a wait state from the manager to the subordinate. So yeah, so the subordinate should not respond anything for that, and whatever is there on the buses should be ignored. So it should not perform anything when master is busy, either fetching of the data or something. And in non-sequential is something like which comes into picture when we talk about the bus. Okay, when you have a size of number of transfers, so bust is basically, as I've said, which indicates how many transfers are happening in one time. One time in a sense, it's not one cycle, it's like one stretch, how many are happening when it is accessing. And H size basically represents in one transfer of this how many bits you are transferring. Okay, so that is the basic difference. And when you are multiplying H size into burst, you'll come to know how many bits you are transferring. Understood? In that whole transfer that happens in between master and slave. Any doubt in this particular, because this is what represents how much data you are transferring. What is burst means. So yeah. Soon after that, so when your burst, which is burst size or the number of transfers that you have, is equals to 1, and this is 1, then that indicates that after the idle, your master should go into non-sequential state. The single transfer for the first transfer or first. Okay, I'll try to do this. So basically, non-sequential says indicates to slave that it is either single transfer or it is the first transfer of the burst. So burst is basically data that is going in, transfers that are going one after the other. So this is how many transfers are going like this is said by the burst size. Okay, this is represented by H burst. How many?
H size na?
Yeah, how many you are transferring, how many bits you are transferring inside one transfer is represented by H size. Okay, now when you are doing either single transaction, that is you are only sending one 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 transfer is happening, so this is called as non-sequential. Also, this one, the first transfer of the burst, is also called non-sequential. These two are non-sequentials. Then after this, after if it is single transfer, it goes back to idle stage. If not, if it is like in this fashion, which is burst, there are still more transfers that are left, then it will go to sequential state. Okay, so that is basic difference. But you don't have to remember all this, because this
Remaining transfers will go together.
one after the other only. Everything happens one after the other, but until the number of the transfers complete, let's say you have some 8 transfers, until the 8 transfers complete, it will not go back to idle state. That's the only thing. And then
In sequential,
yeah, sequential, as I said, after the first transfer of the burst, everything will be remaining transfers in a burst, a sequential in thing. And one thing that is basically differs all, whether it is sequential or non-sequential, is address and control. Address which is there in the previous is not related, because you are basically starting a new transfer, and the first new transfer have non-sequential, so it is nowhere dependent with the previous transfers that are happening before this. Okay, which is the past transfers that happen in the place of sequential, because it is happening and it is a part of the in between the burst. It is the second transfer that is happening after this. So you have a relation between this and this, because they are part of same transfer. Okay, so whatever the address is there, based on that plus H size, you'll do the next transfer. I'll show it in the next place. So here, first you start with non-sequential, and we can see H burst. H burst is increment. So increment says there are some modes in the burst. Increment is one of them, and increment mention that you can increment it by the H size. Okay, indefinitely. It can go unlimitedly, but the maximum that it can go is 1 KB. After 1 KB, it will go back. because it is restricted that any slave or anything that is sitting on the other side should only take the memory access of in 1 KB. After 1 KB, you'll have getting back into the zero for that particular slave. Okay, so this is one of the thing that you need to understand. That it's just about this AHB, so you don't have to particularly know why what for our project. So after non-sequential, you are going into so basic. Now what I'm saying is it is incrementing with in undefined length. So it goes on incrementing until you get 1 KB, and each transfer will have a size of don't have H size here. So here we can see the difference. Each is having 4 bytes. Okay. Any memory that is there in the sheet will have 1 byte. It is everything byte addressable. So everything goes in. Everything that we read here is in bytes. So from 20 to 24, it is 4 bytes. 4 bytes only. So 4 bytes. So the size of that H size will be 4. Each transfer you are transferring 4. Now you have a busy state wherein the master should, the subordinate should make sure that it is not doing any transfer at this point of time, and then it turns to sequential. That means the sequential is dependent on the previous address that is there. So based on 24, it adds plus 4 and it goes to 20.
BC and sequence.
These are relational. Yeah.
BC and sequence will happen in same address. Huh?
Yeah, because in busy you should not do anything and master will not do any changes. Busy in a sense, master is doing something else.
Okay, okay.
So it remains same. It's not like it be same. It should be always same. It can change, but master is doing some other work. Right? So we should make sure that it is stable, and then it goes for the next transfer. And this continues. And at this point of time, you can see you had a wait state because of H ready going down, as similar to P ready that is happening in APB. So this is how it is, and we'll try to go do something on burst because while we are testing, we tested with increment. I think increment 8 and wrap 8. There is something called wrap in burst also. It is not very complex. It is easy when you understand increment. So we tested it for single write, single read, single read and single write. Increment it, wrap it, and these two for read and write. Okay, for write and read, for write and read. Okay. So that's the only reason that we are discussing about AHB, about bursts in the AHB. And then coming directly to the burst, what does those types wrap and increment means? What is increment A? What does that? So that will be the last topic that we'll cover. And before that, we'll try to do something on slave pipelining thing. So you have two things that happen in pipeline. So as we had fetch, decode,
Little louder, Dhaneshwar. Little louder.
yeah. As you had fetch, decode, and execute, then there were memory and write back in the RISC-V architecture. Similar to that, you have something called address phase and data phase as pipelined in AHB. So basically, when first transfer enters, let's say this is T1. Am I audible now? Yeah,
What are the phases?
Yes, audible, audible.
yeah. So this is address phase and this is data phase, which is there here. So let's say you're transferring, your transfer starts with T1, and that this T1 from the address phase, after putting the address on the bus, it transfers to data phase. When this T1 transfers to data phase, you'll have T2. D2 entering into this phase. Okay, so how we had that after fetch, then decode, then it goes. By the time it reaches decode, that instruction reaches decode stage. Other instructions started having fetching, right? Similar to that, when your transfer once address have been written onto the bus, when it is going to data phase, the second transfer will start putting the address in the address bus. Okay, is that clear? So your slave will also be accordingly working. Uh, so this will happen, and in the similar fashion, you'll have this good bit. So it is like just like a two-stage pipeline. Okay. Is there any doubt in this? So basically, this address A is happening here, and data is happening here. When you have address after the next cycle, you have data here. By the time the address, as I've said, by the time this reaches here, your D2 starts getting data, which is P. P is the second transfer address. See, in the address your P have been already started and your A have entered its data phase. So as soon as this enters the data phase, the next transfer start putting his address on the address bus. Okay, that's basically pipelining, how it works. Is there any doubt? This understanding of the pipelining?
No.
Yeah, fine. So that is about that. Now coming to bus transfers. I'll be yeah. So your bus is of size 3 bits and it is free. You can't change it. And then here we have based on the combination of that bits, you have each have its own significance. So major thing that we see is single and then increment and then something called increment and then a constant number which is 4, 8, 16, and then you have wrap. After that you have something called as 4 and you have a constant. So what does this all mean? We'll try to go a brief about them. So basically the single says that you are transferring only one set of transfer. Let's say you have a transfer which h size. I'll try to see where is h size. We'll complete h size and then come back here. So, yeah, h size is of 3 bits and this 3 will say basically about what is the size of each transfer. Okay, and it is recommended to have less than 256 and greater than 32. Okay, the size should be either equals to 32 or greater than 32, but it should be less than 256. It is recommended, it's not mandatory to have that. In order to have a proper successful transfers, we try to decrease it till here. So basically, each of them is sizing as 8, which is 1 byte. So it just increments with twice of that 16 twos, then 32 twos, then 64 twos, then so it increments of like this, and you can directly see it is the same. So based on what this is, let's say you have used 000, which mentions that you have 8 bits that are getting transferred in one single time. So you are writing or reading 8 bits of data in that transfer, and it works similarly with other numbers also. You just need to vary this 001, 010. So it is basically the maximum h size that you can put, the maximum data that you can fetch in a single transfer is is restricted by the physical width of your bus. So if your physical width of bus is 32 and you want to get 64 in a single transfer, it is an error. Okay, it pops out an error that its physical dimension is this much and you are trying to access more than that. Okay, any doubt in this? Okay, so the top last is about burst. We'll try to see it and we'll try directly go to state diagram of APB bridge. Okay. Uh, yeah. Now, so coming back to this, so that one transfer is representing, let's say you are getting it with 000, you have 8 bits getting transferred in that one transfer. Okay, so basically h size, as I say, it is representing in one transfer how many bits you are passing. Burst indicates how many transfer, how many such transfer are you doing in one stretch. Okay, so increment says that you are increment the burst with undefined length. Let's say you are now having at 8 bits. Let's say it is 0x0. As I said, everything is byte addressable. Next one will be 31. So this address goes on incrementing until you reach 1 KB of range. Until you reach 1 KB range, it goes back and gives an error that you have reached the maximum size. So this is happens with undefined length. So you are not defining the length when it should get stopped, when the transfer should be stopped. Okay. In the same way, your increment 4 works, but your increment 4 says that you have a limitation of transferring 4 bits, 4 transfers, 4 such transfers in a single stretch. Okay, so you have a limitation for
Till
that.
1 KB, like this. 1 KB transfer will go.
Yeah, that when you are using increment. Yeah. Okay. Now this, let's say you are initially giving 30, and then it goes to 31, and then it goes to 32, goes to 33. So considering the h size is 000, which is 1 by 2. Okay. In the same way, increment 8, increment 16. It just says that you're transferring, you have 8 transfers, you have 16 transfers. Coming to wrap, that is something which is very much similar to increment 8 and 16. But the only thing is how your address is getting incremented. So wrap itself, by the name itself, says that after something it is getting wrapped. What is getting wrapped? We'll try to see. So basically, if you are starting at 30 and incrementing it one after the other, this is saying, let's say you have a address range in that particular slave from 30 to 34, and after 34 the slave is again writing to 30. Let's say this is the only valid range that you can get valid data from the slave, which we need. So we say to slave that, okay, wrap after you reaching 34. So after 30, 31, 32, 33, 34. Let's say it is 33. Okay, so you'll get 4 transfers. After 4 you need to wrap the address to 30. So your address is getting wrapped to its initial address, so that it revolves around this. So your wrap 4 says about that. We'll try to see. And beat in a sense transfer, 4 transfer wrapping was.
Okay.
That is this very much similar to the transfer. Okay, that wrap is where, yeah, and that 8 and 16 is similar to how it is. So rather than you are wrapping at after 4, you'll go till 8 and then you wrap back. So I'll try to show you. This is, yeah, this wrap 4. So you're starting at 38, going to 3C and 30 and then 34. Now there is no wrap here, but we'll try to see something which is getting wrap. Yeah. So 38 you have, then you have that. This won't wrap because it is just incrementing. It's just at 4, 4, 4. And this it, yeah, here it wrapped now. So from 3C you got to 30, and So this is, it starts at 38, goes to 3C, then wraps back to initial value. Let's say you're starting at here, and this is the initial address, this is the wrap end address, and you're going here, you're wrapping back here, and then you start here, come here. So this initial address and this wrapping address will have some calculation to calculate them, but we don't want to know about them because it's a bit complex and unnecessary for what we are doing. So that's our wrap, how it is getting mapped. So basically the address goes back to the initial value and then wrap and then start taking the data or reading the data from them. So it revolves around a particular address range. Okay, any doubts in this? Okay, so any doubts in AHB, APB? Fine, fine. So we'll start. We'll start with bridge state mission. I'll show. Yes. It's not all. Ada. Yeah, you share to Chetan. This is Chetan's listen. Yeah, WhatsApp. I logged in now. Yeah, okay. I'll try to do my this here. Yeah, I shared it. Yeah, bridge. So this is the overview of the bridge that we actually wrote for the code. So as I said, there should be something that makes sure that APB is going in two cycles, and wherever we want to add one cycle delay, we are trying to add. So we are trying to add them using one flip flop. So this is the whole thing, like how it's internally working, and we designed it one after the other. First, we go with FSM. FSM is already given, or states will be given, and this address decode in our thing we have only one slave. So whatever the address we are giving, it redirects to that slave, and that slave will get active. But it should be in 1 KB range. That 1 KB, I think that restriction we have kept in the coding. And then these are the flip flops that make sure your APB is getting known about the two cycles. So you need to basically have a setup and access from the idle. So you need to have two cycles in order to complete an APB transfer. And AHB transfer will complete it in half cycle. The address goes in half cycle because it's not half cycle, but it's in one cycle you are completing because of the pipelining structure. So that pipelining structure, if you add a D flip flop to that, if you delay it for one cycle, you can make it compatible with APB slave. So that is what basically we are doing. And then in the state diagram, so we have burst as a transfer, and you don't have burst on the other side, which is APB. So how you'll make sure that it is going in that way? How we are making that burst getting on the other side? So that, as I said, that setup and access window or that when period is one and you have still more transfers, so it goes back to setup state rather than going to idle. So that happens when the master at the AHB, which APB bridge, whatever the bridge that we are writing, is acting as a master on the APB. So everything that is connected to APB is a slave, else except the bridge. Bridge acts as the master for all. So bridge takes the data from the AHB, where bridge acts as a slave. But here it acts as a master because on the other side, it is the one which is giving the data or reading the data or initiating the transfer on the API. So for that, so you have a state machine that makes sure that all these transfers are happening as intended, and so state machine basically drops down or on the bottom line it just replicate the behavior of APB master APB state machine. Okay, so we'll try to do that. Baki, this is the interface on the other side. So these are the signals that we take from the slave of the AHP, which is an interface. I've showed there are three blocks in whole bridge. So one block is representing APB AHP slave. So master will give data to the slave. Slave will transfer to the state machine. State machine appropriately select the APB slave based on the interface. So this we have as an interface. So this whole module will combinedly defines what is bridge. Okay. So but in our thing we don't have slave. We are using this interface as a slave and giving the data to just simplify and not write the slave as a one more component. And that's it about what we actually do. This is the one side of the interface, this is the other side. So here bridge is working as slave, here it is working as master. Yeah. And then coming to the state machine, yeah, this is the state machine. To look it, it would be a bit complicated, but so this is basically implemented. So whenever we have a state machine based on the signals, we can easily implement the module out of it. We can easily do a Verilog coding out of it. So seeing this, we'll try to replicate that FSM. So seeing this FSM, we'll try to code it. So it's not big deal to write, but just understanding this is a bit complicated. So it starts with idle. Then if everything runs with respect to valid, wherever you see you have a valid, you have valid based on the valid is basically a control signal, that is making the transfers among the states. So the transfers that are happening, the transaction that are happening among the states is basically based on the value of valid. Okay. So to start with, everything that we see here, I'll try to explain what each state is doing. Okay. So the first state, which is idle, is basically saying that is no transfer is there, and that happens if valid is 0, you're getting it back into the state. If your valid is high and your h write is 1, that means you need to start writing. So writing, as I said, to write you need address and data at the same time for an APV. But in AHB, you have address at one side and data at one side. So because of the pipelining structure, so you need to make sure you are adding 2 cycles after this getting here. So one cycle will make sure that both are accessing both both address and data from the AHB are stable, and that is this cycle from here to here. It will make, so by here the address will come, and when it goes for the next cycles your data will come. So there will be registers that store them, and then you have h write, which is, let's say, you try to see it as an idle. I'll try to make the others.
Bridget is lost in the process because P only insert the first item without removing it. First insert on the
APB.
first node ತೆಗಿ ಫಸ್ಟ್ ತೆಗಿಲ್ಲ ಪೀಕ್ ಗೇಟ್ ಮಾತ್ರ ತೆಗಿ ಪೀಕ್ ಗೇಟ್ ಅಂತ ಬಂತಂದ್ರೆ ಗೇಟ್
APB ಯಾರು
ಗೇಟ್ ಅಂತ
test picture.
ಅದು ಪೀಕ್ ಫುಲ್ ಗೇಟ್ ಬಂದು ಸಣ್ಣ ಗೇಟ್ ಬಂದು
So yeah, try to see make a relation among the state machine and in this here, so it will be easier. I'll try to color code them so that you can understand.
ಈಗ ಈಗ ಟ್ರೈ ಗೇಟ್ ಅಂತ ಕೊಟ್ಟು ಟ್ರೈ ಗೇಟ್ ಬ್ಲಾಕಿಂಗ್ ನಾವು
So ideal state I'll be representing using blue itself. So ideal state here is blue, ideal state here is blue. Okay, then you have setup here as orange. Setup here as orange, and then here setup will change, so I'll not color code it now. And then you have okay, I'm changing here. So you have access as green. Okay, so based on this we'll try to see this one. So let's say your bridge is trying to say that it got a transfer which is right from the APB, okay, AHB. So now when the write transfer occurs, this will be idle state, because in order to that pipelining structure we need to wait for one state so that the data and address get stable and be in the same be available at same time. Okay, so this is similar to what this is. Okay, and then the next cycle which is setup is this based on the value. So this side will come to see when we have continuous transfers that need to be happen. Okay, and then this is the access. Okay, similar to that, when we are reading is basically your address is given but your data is given from the slave, which is APB. So you don't have to have this stability of data, because here it is reading like here it is writing, right? The master is writing to the slave, so you need to make sure your address and data is here. The APB is writing, so you don't have this data path. You don't have to worry about that data phase that is there in AHP. So this is similar to the setup when you are reading, and this is similar to access. Okay, so for the read, this is the thing similar to this. Okay, and in write, this is the process. And when you are doing this one from here to here, which is nothing but write is coming here and going here, so it revolves here. Okay, from here. So this acts as idle, and it comes to setup here when it is continuation. So this, as I said, access will act as idle and it goes back. So this is the process that happens. So basically these three states are our some or the other way getting into this part. So every cycle when you see, it is replicating these three states. So you just need to understand. Try to. It is not that much required to know everything about this. Just need to understand. Okay, how many are there and what is each state doing. You'll try to go with this spec sheet inside, and you'll come to know, because this is what you need to understand by yourself in the first time, so that you'll try to know what is in detail of that. You can post any doubts that are there, or we can do one more 1 hour session for that, a discussion of what are the doubts on the stage in this. So try to do by yourself so that you'll understand it more clearer, and try to question yourself of what it is. And it will be easier to explain to the guy who's sitting on the other side in the interview. So that's the only thing. So this is basically we are getting. Sumukha, can you try to show the codes just uh, how they are actually are? Okay. Okay. Try. No. Yeah. Try to go through everything from first. But start with the state diagram. Understand the state diagram. If any doubts, we'll do one half an hour or 1 hour session again, and then we continue to that session. We'll do the explanation of the codes also, which is sitting where. So in depth of explanation on the codes, you try to understand what each statement is saying, but what each block is saying can be uh, done in the meeting. But rest is each statement, how is it, and how will each statement is related to the theory that we covered today, or the state diagram that you will be reading one more time. So that's it. I think with that you also get clarity. If even after that, if there are any doubts, we'll do one more time. That's not an issue. But yeah, that's it. Is there anything anybody wants to ask? All are saturated. Yeah.